Hello, this is part 4 of the calculator workshop, and in this one we are going to be talking a little bit more about graphing. Specifically here we're going to be finding x-intercepts of graphs and also the intersection of two graphs. Right, so I'll show you how to do some of that fancy stuff with the graphs on a calculator. Right, so if you didn't watch the last one that I did, part 3 of the calculator workshop, where we just went over the basics of how to draw a graph and how to play with the window in order to find the graph, you might want to watch that one before you watch this video so that you understand how to actually draw a graph before you have to do this fancier stuff. So the first thing we're going to do is find the x-intercept of a graph. If you recall, the x-intercept refers to the points where the graph touches the x-axis, right, that horizontal axis. Right, so here's the equation we're going to use to find the x-intercepts. Y equals 5x plus 7. Right, so if you recall, to graph this, I go to my y equals screen. Right, if I have an equation in there, which I do from that last video, let me clear that out, and then I can type in 5x plus 7. So 5, remember the x button is up here, that xt theta n. I hit that for x, and then plus 7. And then enter. So there's my equation, y equals 5x plus 7. I don't remember how I had the window set up, so let me do the zoom button and then number 6 to take me back to the standard window. I'm pretty sure for one of the graphs on the last video, I had to change the window. So now I'm changing it back to the standard, which is between -10 and +10 for the x and y values. And there is my graph of y equals 5x plus 7. And we can see that this graph does have an x-intercept at this point right here, right? Which looks like it's about -1, but it looks like it's not exactly at -1. Right? So it looks like it's close to -1, but not quite. Now, if you're in a math class and your teacher wants you to find the x-intercepts of the graph, they don't want the answer to be, it looks like it's close to -1, but not quite. They want a more exact, a more precise answer. Right? And our calculator will give us a more precise answer. Right? We don't just have to look at this and estimate and say, well, it's about -1.1, let's say. That's close enough. Right? We can get a more accurate answer than that using our calculator. All right, so one thing, first I'm going to show you what not to do. Now, I've seen a lot of students do this before, which is why I'm pointing out that you shouldn't do it this way. But I've seen a lot of students use the trace button, which again, in that last video, we talked a little bit about the trace button. If you hit that trace button, remember, it puts the cursor on the graph and it gives you the x and y coordinates. And then, if you use the arrows, in this case, if I want to find the x-intercept, I'm going to use the arrow to the left to move over in that direction. And I can get that pretty close to the x-intercept, but notice, as I get close to it, it jumps right over the x-intercept. It doesn't land exactly on it. Right? And again, we talked about this in the last video. When you use that trace function, it doesn't land on nice values for you. It just kind of skips a little bit, and you usually end up with weird decimals. Right? So this is about as close as I can get, and it says -1.276 and y equals 0.617. But remember, on the x-intercept, the y should equal 0. But my y is 0.617, so it's not really getting me that close to y equals 0. And so it's not giving me the precise x-intercept. Right? So you can use this to get an idea of where the x-intercept is. It's like between -1.48 and -1.2, whatever it was on that last one that I looked at. But that's not exactly the x-intercept. Right? So to get a more precise value for the x-intercept, I'm going to use the calculate menu, which is up above the trace button. So I do second trace, right? It says calc up there, and that takes me to a menu that says calculate. And here's where you find a lot of the things that your calculator can do with a graph that's already on the screen. So you can calculate a value, right? If you want to do that, if you want to find out what's the value of this function when x equals 4, you can just pick value here, and then it says x equals on your screen. You type in 4, and then it tells you what y is equal to when x equals 4. Right? We can find the 0, which is another word for the x-intercept. So that's the one we're actually going to do here, is to find the 0 of the function. Right? That's our x-intercept. We can find minimum and maximum points. So if our graph has like high points or low points, we can use those minimums and maximums to find where those high and low points are, which is useful for a lot of problems you do in algebra classes and also pre-calculus and calculus classes, finding minimum and maximum points. So those are important ones as well. Intersect, which we'll talk about in the next example we'll do, how to find the intersection of more than one graph. And then down below we have dy dx and the integral of f of x dx. Those are only used in calculus, right? Dy dx is for calculating a derivative at a certain point, and the integral, that's for calculating an integral, and that's something you do in calculus 2 classes. All right? So right now, again, we're doing the x-intercept, which is the 0. So I hit enter, right? And it's called the 0 because it's where the function equals 0. All right, now notice when I hit that, it says down here left boundary. All right, so I need to move the cursor so that it's clearly on the left side of the x-intercept, which it is. All right, so I hit enter, and then it asks me for a right bound. Now I have to use my arrow to move to the right until my cursor crosses the x-intercept and now is on the right side of the x-intercept. All right, so I've crossed over it, I'm on the right side, I hit enter again, and notice when I do those two things, it puts those little arrows at the top. What my calculator is going to do is search in between those two arrows to look for where this function has a y value of 0. And where it has a y value of 0, that's going to be my x-intercept. Right, so that's why the calculator makes us do a left bound and a right bound, right? Because some functions have more than one x-intercept, right? If this graph kind of curved around and came back down again, it would have a second x-intercept. Well, our calculator can only find one of those at a time, and so we do this left bound and right bound to specify to the calculator, I'm looking for the x-intercept in between these 2 points right here, so I'm looking for that one. Or if there's another one over here and I want to find that one too, I would have to do this again and put the left bound and the right bound on that side in order to find that x-intercept. All right, so we have to tell the calculator basically which one we're looking for so that it finds it for us. Right, and then it says guess. Right, so for the guess, I move the cursor pretty close to the x-intercept there, and then I hit enter, and at the bottom it tells me my x-intercept, right, which is x equals negative 1.4, y equals 0. All right, so that's a precise value of where our graph crosses the x-axis. Right, again, looking at the graph and trying to estimate, it was not a real good estimate that we got. Using that trace button, we got close, but it wasn't quite there. Using that second and then the calc menu, the calculate menu, and then finding the 0 gives you the most precise answer you can get on your calculator. All right, so if you're finding x-intercept, you always want to do it that way on the calculator. Never with the trace, never just eyeballing it and making an estimate based on what the graph looks like. All right, so that's how we find our x-intercepts. Right, the next thing we're going to do is find an intersection of 2 graphs. All right, the 2 graphs we're going to use are y equals 5x plus 7 and y equals negative 1/3 x minus 4. Right, so the y equals 5x plus 7, that's the one that I already have graphed there. So let me go back to my y equals screen. Right, I don't have to change that first y1 because I'm using the same one. I have to go down to y2 now and type in the second equation, which is the negative 1/3 x minus 4. So I do y equals, I do negative. Remember, to type a negative number, and we talked about this on the first video of this workshop, don't use the subtraction key over here. Right, to type a negative number, you use this negative in parentheses down below. Right, so I do negative, and then let me do parentheses 1/3. Right, so again, just so I keep that fraction together, right, that's the fraction 1/3 x. Right, so once again, our variable button is up here, and then minus 4. For the minus, I use the subtraction key over here, not the negative key down below. Right, and that's a common mistake people sometimes make when they're first using calculators, or even if they've used them a lot, and sometimes it just happens, mixing up the negative key with the minus key. So just be careful of that as you're working with your calculator. All right, so it's negative 1/3 x minus 4. My y1 is 5x plus 7. And now I want to find the intersection of these two. So I hit the graph button again, and there's the 5x plus 7 is already there, and now it's drawing the new one, the negative 1/3 x minus 4. And we can see there's an intersection of those 2 graphs right down in there. All right, and once again, if you know something about the types of functions you're graphing, right, both of these are linear functions, meaning that the graphs are straight lines. If you have 2 linear functions that you're graphing, they're only going to get one intersection point, unless those 2 linear functions happen to be the exact same function, in which case it's basically the same line all the way through. Right, but if you have 2 distinct linear functions, they can only have one intersection. So I know here that that's the only intersection these 2 graphs are going to have. Right, if one of these was like a quadratic function that's like a parabola, like say this one here was a parabola and it came up again over here, well then there might be another intersection somewhere off the screen that I would have to play with my window in order to find where that intersection is. All right, so again, you can't just rely on your calculator to do everything for you. You do have to have some knowledge of what the functions look like and what the graphs look like, so that you know, is this all of the intersections here, or is there maybe another one that I'm not seeing off the screen somewhere, and I need to make my screen, make my window bigger to catch all of these things. All right, so again, your calculator won't do it all for you. It only does what you ask it to do. You have to bring some prior knowledge to it to make sure you get everything that you need. Right, but in this case, like I said, with the 2 linear functions, they're only going to have the one intersection, and that one intersection is right there on our screen, and so we are now able to find that intersection. Right, and once again, to find that intersection, just like when we did the x-intercept. I don't want to just eyeball it and say, okay, the x value looks like it's about -2 and the y value looks like it's about -4. That's close, but again, that's an estimate. We want more precise answers, right? And again, I don't want to use the trace button like I did before, because like we said, that's probably not going to land on that one exact point where they intersect. It's going to get close to it, but it's probably not going to land right on it. Right, so what we want to do is go back to that calc menu, right? Second trace to get to that calculate menu, and this time I want to find the intersection, so I go down to number 5, which says intersect. Makes sense, right? All right, so I choose intersect, hit enter. Now this time, not like the x-intercept. The x-intercept made me do the left bound and the right bound. We don't have to do that for an intersection, right? To find the intersect, it asks me for the first curve, and notice it puts the cursor automatically on the y1 for me. So that's my first curve. I just go ahead and hit enter. It asks me now for the second curve, right? And notice it puts it on the y2 for me, right? It's telling me up here which equation that cursor is on. So right now it's on the y2. That's my second curve, so I hit enter. Then it asks me for a guess. For the guess, you could just hit enter again, but if you move the cursor a little bit closer to the intersection point, it's probably going to find it a little bit quicker. All right, so I hit enter. And then it gives me the intersection point, right? It puts the cursor right on that point where they meet, and it tells me that x equals -2.0625 and y equals -3.3125, right? So it gives me a very precise point of where those two graphs intersect, right? Much better than just eyeballing it or using that trace feature in order to try to figure it out. All right, so that's how we can find the intersection of two graphs. And the reason this makes us choose the first curve and the second curve is because remember, we can, like on my calculator there in that y equals screen, I have 7 listed, so I can graph 7 equations at the same time. But your calculator can only find the intersection of any 2 of those at once, right? So if you have more than 2 equations graphed, you have to tell the calculator, I'm looking for this one and this one, find the intersection of those 2, and ignore all the other ones that are on the screen. Right? That's why it makes us do that first curve, second curve thing. All right, but that's how we can find our intersection of graphs, and that's useful when you're solving like systems of equations. When you're solving problems that involve 2 equations with 2 variables, the graphing method, you graph the 2 equations, you find where they intersect. That gives you your solution to that system of equations. All right, so that's where this is useful, and some other application type problems as well. All right, so that's, again, some of the extra stuff our calculator does, with not just graphing it, but then using that graph to actually find information, finding x-intercepts, finding intersections. Remember, it can also find minimum and maximum points of curves, high point or a low point on a curve. So your calculator is a very powerful tool. It does a lot of stuff. You just have to know how to tell it to do the thing that you want it to do. And that's really the key thing, is knowing how to punch the stuff into your calculator to get what you want from it. And really, the best thing that you can do for that is just practice it and do it over and over again. And the more often you do it, as far as like drawing graphs and finding intersections or x-intercepts, it gets to a point where you don't have to think about it every time. You say, okay, I have to find the intersection, type in the equation, do the intersect, okay, there it is, I got it. All right, so play with it, practice with it, and you'll get it. All right, that's the end of this 4th video. I lost count. I think this is the 4th video of this calculator workshop. The next one that I'll do is going to cover some financial applications using what we call the TVM solver, solving for money and interest rates and stuff like that. So it's another pretty powerful tool that your calculator has as part of it. So make sure you check out that part as well.